Hello, everyone. Welcome to the third installment of our PaxCon Reflections webinar series. Today's topic is stream restoration and stormwater management. We're so happy that you took the time to spend your lunch hour with us. My name is Teresa Worden, and I'm a program officer at Maryland Humanities. It's my pleasure to host today's presentation. Please be aware that we are now recording this session. If you do not wish to be a part of this recording, you may exit the webinar. We are posting all of the recordings on the PaxCon website. So if you do leave us, you can return and watch the presentation at your leisure if you prefer when it is posted on the website. Just a few notes before we jump into the presentations. You should have the ability to control your own microphone and video. You're not required to turn on your camera, but we do appreciate that you remain muted while the presenters are speaking. We do appreciate in advance your grace and your patience. Should we encounter any technical difficulties on our end, we will do our best to resolve any of the issues as quickly as possible. We are monitoring the chat window where you are going to submit your questions to our speakers for the Q&A. The Q&A is going to take place after both of our presenters have spoken. To open the chat window, find and click the chat button at the bottom right of your screen. To open or minimize the participant windows, use the participant button, which is next to the chat button. There's also a way to take notes with the WebEx platform. It's a pretty cool feature. To do this, click the three dots next to the chat button. When the webinar ends, your personal notes will be downloaded to your computer as a text file. This year, we are celebrating the 5th year of the PaxCon River Conference, and the planning team was really looking forward to hosting an in-person conference to reflect on the last 5 years of work in the Patuxent River watershed. But in keeping with so many adjustments we've all had to make this year, the PaxCon Reflections webinar series was born out of moving this experience to an online format. We focused the series on topics that you, our attendees, rated as most important to reflect on. This included local impacts of climate change, wetland ecology, stream restoration and stormwater management, and outreach and advocacy for improved health, river health and ecosystem. Feel free to use the chat to introduce yourself and introduce yourself and tell us where in the Patuxent River watershed you live or work. We love to hear about your favorite spot that is along the river as well. This chat can be a good place to connect and engage with other people, even though we can't network and meet in person. If you'd like to keep up with PaxCon in general, we invite you to access the webinar series and visit our website at paxcon.org. I also want to recognize and send out a huge thank you to our webinar series sponsors for their generous support. PaxCon Reflection sponsors are Bourne Environmental, Chesapeake Bay Natural Estuarine Research Reserve, Maryland, Maryland Humanities, Maryland Indian Tourism Association, and Patuxent Tidewater Land Trust. Also, remember that the final session in our series is November 19th, where you can spend an hour with Patuxent and Anacostia River keepers discussing how they engage communities in caring for local waterways and advocating for improving river health. We expect it to be a lively conversation as the river keepers will be addressing questions submitted by registrants ahead of time. With that, I'm happy to introduce our speakers today. We're thrilled to welcome Dr. Solange Filoso and Erik Michelsen. Dr. Filoso is an associate research professor at the University of Maryland Center for Environmental Science, where she has been a faculty member since 2008. In Maryland, her research is primarily focused on understanding the effectiveness of watershed management strategies such as stream and wetland restoration at mitigating the impacts of nutrient pollution and other human activities on streams and rivers draining into the Chesapeake Bay. The goal of her research is to contribute scientific information that will help our ability to protect and restore the functional capacity of freshwater ecosystems and sustain aquatic life in the Bay region. Erik Michelsen is the acting deputy director of Anne Arundel County's Bureau of Watershed Protection and Restoration. He is charged with managing its restoration effort to clean up the county's waterways and satisfy its municipal separate storm sewer system and Chesapeake Bay total maximum daily load requirements. Please forgive a brief pause as we hand over control to our first speaker.
Okay, can you see my screen?
Yes.
Okay. All right, thank you, everyone. I'm Erik Michelsen. I'm the Deputy Director of Anne Arundel County's Bureau of Watershed Protection and Restoration, and I'm very pleased to be here talking to you all today with Solange. We go back a long ways and talk about these issues all the time and have for years. So I look forward to seeing her portion of the presentation when that's ready, and I think it'll dovetail nicely with what I'm going to talk about here too. So in Anne Arundel County, we've been doing stream restoration for a number of decades now, really have focused on stream restoration from a water quality perspective for about the past 15 or 20 years primarily. Before that, most of the restoration that was going on was really aimed at infrastructure protection, so roads or properties or utilities infrastructure that was exposed. And I think, that's conventionally been a lot of the stream restoration field is just sort of armoring streams in place to make sure that they aren't disturbing the developed landscape. But I'm going to talk again about stream restoration from a water quality perspective and how we've used a lot of the great research that's come out of the region to inform our methods going forward and the approaches that we've taken. This slide is from some of Grace Brush's work. She's an emeritus professor at Hopkins who has looked at the historical land use in the Chesapeake Bay region. And one of the things that's really fascinating from her work and others now is the extent to which beaver dominated the landscape in the pre-colonial period, that these lowland areas that we see now where our streams are located are sort of ditches dug down through the soils in these valleys are located. We're mostly probably impounded valleys with a series of beaver ponds and dams, and then perhaps areas that were unimpounded or had, where the impoundments had failed and were riffles. But beaver were all throughout the landscape, and really the natural history of this topic could its own set of presentations. So I won't go too far into it, but it is fascinating. And a lot of the work that's out there suggests that, again, these systems were essentially the lowland areas were completely occupied by beaver, and the uplands, were forest largely or were being managed by the indigenous population. And so we see remnants of that in our work today. It's not uncommon at all in the valleys in Anne Arundel County, the coastal plain valleys, where you'll see issues like this, where there's old tree stumps that are buried several feet into the legacy sediment muck. Obviously, those tree stumps weren't at that location when the trees are, that soil that's there wasn't at that location when those trees were growing, and has been deposited since those trees died, most likely. But we see these kind of remnants of recent disturbance, and the legacy sediment story that's been told by folks like Dorothy Merritz and Bob Walter at Franklin and Marshall University is probably pretty familiar to a lot of folks on this call. But the idea is that the pre-colonial or the post-colonial, landscape was cleared for agriculture and for other kinds of purposes, and that soil, oftentimes very erosive soil, ran off down into our stream valleys. Ended up oftentimes, but not always, being caught behind mill dam features, which were present in the coastal plain. Anne Arundel County has a pretty rich history of mill dams. Most of those you have to look very hard to see these days. It's not like in the New England or upper mid-Atlantic where you had stone features that still, oftentimes remnants of those still exist. Many of these were earthen dam features were fairly ephemeral in that regard. But this is a situation in Davidsonville in Arundel County where I'm standing on probably 15 feet of legacy sediment behind an old dam, and you can see the stream ditch that's cut down through that material after the dam breach, and you know, lots of folks might come to the site and say, well, that's, you know, maybe the result of urbanization or some other kind of factor. This is a watershed with almost no development activity in a very, very dense riparian forest. In terms of understanding the mechanics and the processes for stream restoration, I think that this model developed by Harmon and Starr really does provide a valuable set of insights in that this the sort of the base level of all the things we do with regards to stream restoration really flows, pardon the pun, from hydrology. It shapes the hydraulics of the system and the geomorphology of the system in terms of the shape of the system. And then some of the things that both Solange and I will be talking about are really the physicochemical, so the nutrient and sediment processing, and then of course the biological, which is what the endpoint that we hope to see in a lot of these systems. And for a long time, in the stream restoration field, there was an assumption that really the best you could do was come in at about level 2 here with regards to modifying the hydraulics potentially, or maybe even just modifying the geomorphology. But I think as we've gotten further into this field and seen the results of the kind of work that I'm going to talk about here, that we really realize it's very possible and critical, frankly, to modify that hydrology element of these features. As I say, most stream restoration itself is still a pretty young field. It's been going on in this area for 20 or 30 years, but that's not a really long time frame. And a lot of it was aimed at building transport reaches initially. So bankful channels, basically trying to build systems that would transport both water and sediment without aggrading or degrading, because there was concern that if there was aggradation, the features that were constructed might fail. And of course, if there's degradation, the original issue that was trying to be addressed would be persisting in terms of stream erosion and that sort of thing. So many of the systems that we have seen historically built in this region in North Carolina, other places, Virginia, were transport reaches. And you see a fairly common theme to those approaches in terms of oftentimes these sort of sinuous rock line channels. I like to say that they're sort of what we think, maybe in an idealized way, a stream might look like, and they oftentimes do have an aesthetic appeal to them. But there's a lot of questions about whether or not that kind of system is the kind of system that's the best for processing nutrients or providing the kind of biological habitat that we're looking for. And of course, some of that work is done more or less gracefully than others. This is a pretty unfortunate example of, you know, an effort to basically do infrastructure protection and in the name of stream restoration. But it's not uncommon to see those. And then another thing that we see, and we've sort of seen this more frequently too, is the attempt to involve more quote unquote natural materials. So there's been a strong preference for trying to bring wood into these systems instead of stone, especially where there isn't sort of native stone present, or that's not a material that is naturally occurring. But unfortunately, a lot of times, and this really gets to that geomorphological component, the wood is used simply in the same way that the stone had been used previously, which is to provide some armoring, to prevent material from moving around, and really not in the way that wood occurs oftentimes in these natural systems, which is interrupting flow, creating roughness. And you'll see that in some of the pictures that I'll show later on. So the industry and the practitioners, like the folks that work with me and others, really have been faced with this sort of decision point. You know, are we going to continue to build these transport reaches, especially when we're trying to reduce the amounts of nutrients and sediments that are getting downstream, that have the same kinds of issues and that, based on the science, really don't appear to be quite very effective at those kinds of things. Or we're going to build retention reaches, or we're going to build systems that try to grab the carbon that's moving through these systems and store it, lock it up, that basically try to get the water to stay on the landscape and get into the ground for as long a period as time, rather than getting vented downstream. And we've made the decision in Arundel County really to focus on retention much more aggressively, and really try to avoid transport, except for the instances where it can't be avoided. And so, let's see here. Okay, so here's an example, and actually, it's a great time of year to be going out to streams to see whether they're transport reaches or retention reaches. This was not taken this week, but it could have been. You can see in this step pool system that we've installed in an outfall area, basically how much of the leaf litter basically racks up in those pool systems and remains, both as habitat and then also as sort of a key building block in that nutrient processing situation. And so we've got systems like this all throughout. And as I say, the idea is that water is going to take as long as possible to get from the top of that system to the bottom of the system, and that all of those other kinds of things get incorporated into the project, into the site for habitat benefits. So, this is an older site, North Grays Bog up in Pasadena, a mature site, really a perennial site. Was an old dredge spoil site, believe it or not, and just turned into a beautiful, beautiful stream and wetland complex, which is what we're aiming for with these systems. Part of the issue, or part of the reason I think for the success of this system, is that the area is very sandy and there's just incredible groundwater contributions. What we're trying to do again here is to convert surface water to groundwater, take it in at a higher elevation in the system, convert it to groundwater so that it ends up base flow, gets that nutrient processing as it gets down through the soils and plants. Cowhide Branch in Annapolis, another stream and wetland site. Believe it or not, this is below the Annapolis Mall and the Anne Arundel Medical Center, at the intersection of Jennifer Road and Admiral Drive. It's a very urbanized watershed, but it's turned out beautifully, and it's an incredible project. We're real happy with how it's turned out. This is, you might say, looks like a reference system, or at least in my opinion, looks like a reference system. What we're really aiming for, and like I said, you see that wood in this system where it's basically completely saturated, where it's slowing down flow, where it's creating roughness, where it's providing habitat. This is Smithsonian Environmental Research Center down in Edgewater, a site that they're actually studying nutrient and sediment processing, and also macroinvertebrate and fish habitat. Really looks beautiful. I like to say we're sort of we're in the business of creating swamps, and that's a pretty good example. And then one of the things I'll talk about too, and getting back to the original Grace brush work, is that we very often see, and Solange and I were talking about this last night, that even in these restored sites, or oftentimes after these restored sites are set up, beaver move in. So this is the Will Eleanor project in Edgewater, where beaver have dammed intermittently that site repeatedly, really enhancing those sites, and something that we embrace in terms of our projects. You can see the river otter here scurrying off to the side. Habitat for all the sorts of things that great blue herons eat, amphibians, little fish, all that good stuff. And this is actually from Solange's work from about a decade ago, where she was looking at, again, the performance of this system in comparison to a transport system upstream. And these are various hydrographs, which is basically how fast the water is moving through those systems. You can see the upstream transport system is very spiky and very flashy, whereas the downstream retention system, which is the line in black, is much more muted and slower releasing. And you can see actually that the base flow extends well beyond that storm flow event. So again, providing that function of dampening the storm flows through the system, which gets you all sorts of opportunity for nutrient and sediment processing, as well as provides the opportunity for flood attenuation, particularly in smaller events. This is a Patuxent specific project, so I wanted to include it. This is a couple of my project managers down in one of these gullies on Towser's Branch, which is a tributary to Little Patuxent. You can see a good 15-foot size gully that went for thousands of feet. That was definitely a transport reach, especially after it had been heavily incised. We came back in this past year and created one of our step pool systems through this area where there's tons and tons of water that gets stored in that system, slowed down through the landscape. And in this watershed that's extremely sandy, soaked into the ground very quickly. So this was an ephemeral system before we restored it. It's going to turn into basically a wetland system throughout the reach, and most of the water, especially for smaller events, is hardly even getting to the bottom of the system, basically being converted to groundwater. One of the other things that we see a fair amount is exposure of utility lines. This is Cat Branch in the Magathie watershed where there was a sewer line exposed in the system. We weren't doing the work primarily to protect the sewer line, but we were able to work with our utilities folks to do a project that did provide that protection. This is that site after restoration where we brought the whole valley up. You can see the groundwater just completely inundating. This is last winter time. This is that site this summer. Basically a beautiful stream and wetland complex, very slow moving water through there. There are beaver below this system, and we expect them to move up into the system for too long. And, you know, one of the things with stream restoration, and Solange will get into this too, I'm sure, is this question of, you know, are some areas too urbanized to repair or restore? And we don't think so. This is Furnace Branch, which was a concrete trapezoidal channel in Glen Burnie, basically no stormwater management in the watershed. This was state-of-the-art stormwater management in 1965 when it was installed. But it's about a 40 or 50% impervious watershed. And that was what folks had lived with for 50 years. We went in and said we could do better. And in the last year or so, completed a restoration project there where we basically removed that concrete channel, created a shallow, broad stream and wetland complex that's really thriving in that location now and providing an opportunity for, again, dampening the hydrograph, providing obviously lots of opportunity for carbon sequestration, carbon retention, and then habitat for a whole variety of critters in there. And so we'll happy to take more questions in the Q&A, but we're very excited about the possibilities in terms of stream restoration, and we're also very interested in staying plugged into the science because we recognize that that's so critical in developing effective and sustainable projects long term. And I'll just hammer this point home one more time, that basically, you know, from a stream restoration perspective, my perspective is that if you're not modifying that hydrology, you're not trying to change hydrology, you're unlikely to see all the other kinds of benefits, including nutrient and sediment processing that we're talking about here at those other levels of the pyramid. So that should really be where we're starting from, I think, in our design approaches and what we're looking for long term. So thank you, Teresa. Appreciate it.
Wonderful. Thank you. All right, so I'm going to switch over to the next presenter.
Okay.
How does that look?
That's fine.
Okay, and you just let me know when to switch.
Okay, that's fine. Okay, so I apologize for all the the technical problems, and I appreciate the help from Teresa and Nicole. So anyway, I'd like to thank you also for the invitation to talk today and for the people watching it. So next, please. So I'd like to start the talk today just by briefly, describing the difference between a healthy stream and a degraded stream. I mean, we can see, the difference, But I just wanted to point out that the main things that a healthy stream, the main characteristics that we seek to maintain in a healthy stream is that complexity of environments. So you can see that a healthy stream has pools and riffles and runs, different velocities of flow, a variety of biomes and ecosystems, and so you can have a riparian forest and sometimes floodplain. And then when you go to a degraded stream, you have this homogeneous system that almost looks like a pipe, especially in urban areas. And so you don't have that complexity. The system oftentimes is incised and unstable, so there's a lot of erosion, and of course then there is lack of biodiversity. So next, please. And one of the main concerns, besides looking bad and not sustaining biodiversity, degraded streams also lose their capacity to maintain processes that are really important at supporting functions that in the end deliver services and goods to society. So, for example, degradation leads to the loss of function of streams to process and retain nutrients. So you can see on the left, this little figure of a stream with like a spring that represents nutrient cycling, for example. So when you don't have anything for nutrients to hold on to or to retain the nutrients, the stream ends up being a pipe, and so pollutants and nutrients end up leaving the stream very fast. And other things include degradation also lead to the loss of control of capacity of streams to control floods. They are really important because the streams, especially headwater streams, they attenuate the flood flows or waves going downstream, and the capacity of stream to moderate sediment transport. So there is no balance between erosion and deposition, and so you end up seeing a lot of transport of sediment downstream. Next, please. And so, it's important to keep in mind that all the degradation that happens in a stream is not just a local problem. Streams are integrators of environmental changes at multiple scale, going from global. So when you think about climate change, regional to the watershed modifications in the surroundings, and then finally to the stream channel. So when you think about a reach, you also have to consider changes upstream, and so it's a whole set of changes that need to be taken into consideration. So next, please. So when we think then when we think about what should be the ultimate goal of restoration, as Erik talked about, the ultimate goal is to move a degraded ecosystem, a stream ecosystem, to a trajectory of recovery that is informed by a reference system, but keeping in mind, this is very important, the local and global environmental changes. So we can't be naive to think that streams are going to go to like a pristine condition, but we do need to just help the ecosystem get to the trajectory that can be self-sustaining. Next, please. And however, which I think is unfortunate. I mean, Erik and I talk a lot about this. Despite the multiple scale processes that lead to the degradation or the health of streams, usually management is done at the reach scale, as Erik mentioned, because of all sorts of reasons. I'm not going to talk about it here, but that's how it's done. Next, please. And in Maryland, as we know, a lot of the stream restoration that is implemented, especially in the past decade or so, is really focused on urban areas, because urban areas in Maryland are growing sources of pollutants. So these two figures here, these maps, from the Bay, the Chesapeake Bay program, they show in red areas where the load of nitrogen and phosphorus from the watershed to streams, whatever is loaded to streams goes almost, goes like 75 to 100% of that in the red area goes straight to the, downstream to the bay. And meaning that, it's an indication that the streams in these areas have lost totally their capacity to retain anything, or most of these pollutants, and this is becoming a big problem. And so apparently, pollutants from urban areas, like the biggest growing area of pollutants going into the bay. So next, please. And so, as you can imagine, with a lot of restoration that has been implemented, so there is a lot of stream restoration that has been implemented here in Maryland, as Erik said, to reduce the loads of these pollutants to downstream waters and eventually to the bay. So a lot of restoration that is being implemented lately is to meet TMDL goals to reduce loads to coastal waters. And so with that, there is a high expectation, or people really want to know if these systems or these restoration projects are working, and that's where I come in. It's amazing that for the past 10 years or so, I have spent most of my life inside of streams, sampling and monitoring to determine if, to kind of quantify the efficacy of restoration. So this is a list of streams that I have monitored in the past, decade. And then you can see that the streams, they have different size watersheds, different levels of imperviousness. Some of them are lowland streams, some are headwater streams. They're in different watersheds. Most of them are in coastal plain. I do hope to monitor more streams in Piedmont. And they also have been restored with different restoration methods. So I'm going to just show you in the next slide what is that, not the next, but soon, what we have found about, what is happening with restoration, if it's doing what we are hoping that they do. Next, please. And so just this is just a quick slide just to show how we monitor. So just to highlight the fact that we need to monitor these streams for quite a, for a prolonged period of time, to include base flow conditions or normal flow conditions, but also high flow conditions during storm flow. And then depending on the rain size or the magnitude of the rain, we need to, the transport or the loads are different. So we need to cover as many rain sizes as possible. So it's a long process to monitor them. So next, please. And so here is like a big summary of, the findings of all this work. And so I'm going to try to navigate and help you navigate through these figures. So basically, the figure that has the blue bars, it represents changes in nitrogen, total nitrogen loads from pre-restoration, in the streams monitored from pre-restoration time. So when the bars are going to the right, means that there was reduction, so it's like, up to 60% of the total nitrogen loads in these monitored streams were reduced from pre-restoration levels. So that's good. So, but you can see that there was variability among projects. Some streams did better than others. Some projects did better than others. And you see the same thing with regard to loads of total suspended solids, TSS, with the orange bars. There was more variability, and with the bars that go to the left, they indicate that there was no retention, actually. So there was actually export, and the same with the TP, the total phosphorus loads. And what is interesting is that even though there was variability, we saw that the streams that were, the projects that were implemented in headwater streams were, had a more solid performance. That's what is highlighted with, with the red in the bottom of these figures. So and this is an interesting finding for that I think has management relevance. Next, please. And in fact, we did see that there was a negative correlation, a significant correlation, negative correlation between the level of performance of this restoration and the size of the drainage area of the stream. So the stream, the streams that had higher, bigger drainage areas performed, less in terms of retaining or reducing loads than streams with the smaller catchments. Next, please. And also we found that load reduction was negatively correlated with imperviousness in the catchment, which is a very interesting finding. So basically, the more imperviousness in the catchment, the less, the lower the performance of the restoration, which is not surprising. There are several reasons that, probably of why this is happening. I'm not getting into this, but nevertheless, again, this is an interesting finding that can be relevant for, for management in terms of deciding or selecting sites for restoration that will be more likely to result in a positive outcome or the expected outcome. This is, this is data from a very few, or limited number of sites. And so it's hard to make a final conclusion that imperviousness is something to be considered, but we do think it's an important finding that should be taken into account. So next, please. So we think that this is an important finding, the imperviousness and the influence of imperviousness level on the performance of restoration for reduction of pollutant loads, because of two things. One is that urbanization is increasing in the Chesapeake Bay area, and also there is the prediction, or that climate change in the region is going to increase the frequency of large storms, and therefore, the volume or the production of generation of surface runoff. As we discuss a little bit on this at this paper that was published just a few years ago. So next, please. And in this paper, we actually then, just to kind of have an idea of the magnitude of the impact of urbanization and increase of impervious areas in a watershed, combined with increased frequency of large storms, we used the Patuxent Basin, and the whole basin and subcatchments of the basin where there were gauged. So we had discharge data just to calculate how much the increase in the frequency of large storms and in the amount of runoff would affect the load of pollutants, nitrogen, phosphorus, and sediment going out into the bay. And what we see, so, this figure here on the left, you see, these bars that show for different parts of the Patuxent watershed, so the number one is the entire Patuxent watershed. Two is the above buoy, and then the little Patuxent. So you can see that these three areas have different levels of imperviousness or urbanization. And what we estimated is that the level of nitrogen, or the amount of the nitrogen loads, phosphorus loads, and sediment would increase from about 14% to 26% with increasing imperviousness. 14% for nitrogen, 14 to 15% for phosphorus and 16 to 33% for total suspended sediment loads. And so what this means, I mean, I'm going over this a little bit too fast, but what I want you just to think about, to get out of this, is that it looks like, when you think about how these restored streams are performing in terms of reducing loads of these pollutants to the bay, some of these projects are reducing loads by 30%, 20%, whatever. So it looks like with climate change and also increased urbanization, the effects or the effectiveness of restoration is going to go down even further. So it basically, it is possible that we'll cancel out the pollutant load reduction that is, seen in some of these projects or even future projects. So this means, so next please, to me, and Erik is probably tired of hearing me saying this, but what I think that we need to do is that we need to start thinking more seriously, or think more outside the channel. That's why the title of the talk was like the story from inside the channel. We need to think more outside the channel. And what I mean by that, for solutions to reduce nutrient loads to the bay. And what I mean by that is not that we shouldn't be doing stream restoration anymore. We should, but in order to even help stream restoration to perform and then, to increase the probability or the possibility that we can meet TMDL goals, we need to start implementing other BMPs in the watershed, in the outside of the channels, especially because, as Erik said, we are just restoring stream reaches, and these reaches can't do miracle. And so even when they perform well, there's just so much they can do. At the same time, we have to recognize that there are challenges such as, lack of riparian floodplain space. I mean, there are places that you can't possibly do everything that is needed. We also have to take into consideration legacy impacts from land use changes in the past, and of course, socioeconomic and institutional barriers. So people are tired of me saying the same thing, but I do hope that we come up with more solutions to meet our TMDL goals, but also to improve the health of the bay in general and of downwater downstream ecosystems. So thank you.
Okay, this is Nicole, the host moderator. We had, or the chat moderator, sorry. We had a very engaging chat going, but I was trying to keep track of the questions. And Erik, thank you for replying to some of those in the chat, which was great to help out. I think a big question, and that connects both presentations, is kind of both for both of you, but how can we connect the research side, the academic side, what you all are learning, with the bidding and construction process that's happening across counties to make sure that things that are getting built within the next 5 years or so, are designed right now to be put in the next few years, are meeting some of these, new design features and things like that. Do you have any thoughts on that?
I'll jump in real quickly. I think that there's a couple things. One is that the Bay program's expert panel report on stream restoration that created a set of crediting protocols for stream restoration and other practices has been really, really helpful. It's been pretty transformative, I think, in some respects in terms of the work that's been conducted. And I'm sure folks, there may be some misgivings, or there may be areas where it could be improved. But I think as a starting point, I think as something that's been revisited, it's a great place to sort of be shaping this work. The other piece that I'll say is that I really think it's important for both researchers to be reaching out to practitioner community, and to frankly be getting themselves in front of the practitioner community at conferences and that sort of thing, as well as for practitioners, of course, to be reaching out to the researchers who are doing this work. We're really fortunate that we've got several folks from University of Maryland doing studies on our projects. We've got people at CERC in Edgewater doing research on our efforts, and folks in Virginia Tech. And so it's really part, I think, of, in terms of being from a manager's perspective, in terms of making yourself aware of the science that's out there and having conversations with the researchers who are doing this work. And again, Solange and I have talked a lot about this, is that, you know, researchers have to get out of their bubble too and make sure that folks are being exposed to their work. So it's something that I think really only happens with active engagement of all the folks in this field who care a lot about this issue.
Can I say something too? Can you hear me?
Yep, go ahead.
Yeah. So, you know, this is also something that, you know, I talked to Erik about and I talked to others. I think that one of the things that scientists can help to is to, help with the expectations of restoration for example, improving water quality or whatever. I mean, I think that in any kind of management, goals for management, you need to set outcomes that are realistic. And I think that when it comes to, the capacity of stream restoration to improve water quality and reduce loads, I think that we are really setting sometimes expectations that are unrealistic. And so my hope is that the kind of information or scientific information that we provide in these studies can really be used to, like in a adaptive management kind of fashion, where goals are reset and expectations are reset, and also that the communication is open. I mean, I think that Erik is right. Scientists live in a bubble sometimes, but I think that promoting engagement where we can come and participate in the early stages of planning, whatever, would be helpful too. But I do think that sometimes expectations are off, and that's why it creates bad reputation for scientists and also for management. Scientists, because we complain, that way it looks like we are just criticizing, but we're not, just like showing the facts, the data.
Great, thank you. Yeah, and I think that management piece also comes in. There were some questions, about climate change and these more flashy storms. How really I think Solange, you said it great. Like, we can't just expect one thing to be the answer. It has to be implementing lots of best management practices and thinking more big picture, not just that stream restoration is the only answer. Real quick, because we have about 5 minutes left. What is, for each of you to think about, what's one thing you wish that you had known before starting this work? Like, what's something that, thinking back on your time, that you're like, gosh, I wish someone would have shared this with me when I first started?
I guess I wish I would have known how hard it was to change people's minds. Although if I had known that early on, I might not have gotten into the field. So it's certainly been an education in as much in understanding the science, the biology, the chemistry of this work as it is in trying to persuade and trying to change paradigms, and oftentimes in these cases, and really get people thinking about things differently than maybe they were originally trained in, or trying to advance the field. So that's maybe, I don't know, that's a tough question to answer, but that's my quick answer.
And for me, I think what I wish I had known, and I'm always learning, but as how difficult, I mean, the complexities of of management, and the community that is in charge of coming up with plans and all that, they are constrained, and I didn't know that. And so as a scientist, I think, I wish I were more out of the bubble in the beginning, because then I could also direct research that could help answer some questions and, and help find easier ways to do things or more effective ways of doing things. So anyway, I'm learning. And so I think that the main thing is like to keep transparency and communication at all times and involve scientists in early stages of planning.
Great, thank you. And that leads to just our last question, which is, how would you recommend that we encourage other counties in the Patuxent River watershed or other municipalities to follow the lead that Anne Arundel County has shown, or like what would be your advice to those of us that are on the call who either work for these groups, municipalities, counties, or who are, constituents that live in these areas?
Well, certainly I'd say our door is always open to folks who want to get field tours or to understand better what we're doing. We actually had a group up from the Calvert County Soil Conservation District looking at some of our projects just a month or two ago. And we routinely host educational groups or other professionals who are interested in doing this. We actually got sort of a pending meeting with folks from Fairfax County at some point soon. We're very interested in sharing information, trying to be as helpful as we can to folks who are interested in learning more about what we're doing. And like I say, there's an open invitation. If you or folks within your jurisdiction would like to learn more about what we're up to, we're happy to help.
And on my end, I encourage the communication with not only people that have experience, in the, on site like Erik, but with scientists. One of the things that is a problem, as you know, in the scientific process is that sometimes when it takes a long time for reports to come out or for publications to come out. And so I think this kind of situation, of opportunity to communicate with the public and inform and educate and all, it's really important. And I'm open at all times to talk to people at all levels, and it's a great pleasure for me. I have more pleasure talking about this with non-scientists, to see if I can help somehow. I don't have all the answers, but at least share my experience and my knowledge, and then talking to other scientists. But anyway, I think it's also important to get perspective from different experts, not just people that like me, that are expert in water quality, for example.
Great. And we have time for one more question. So big picture, and kind of goes along with what I think Solange, you spoke about a little bit, but what would be your expectations for both you and Erik for future conditions or trends as they relate to the Patuxent River watershed? So as you're thinking about your work or the things that you're researching or implementing for now or into the next 5 to 10 years, what are the things that you're thinking about?
Well, I know that urbanization is something that is growing, and so I'm really concerned about it. I am totally for, if I have to advocate for anything, and this is something that Erik and I don't agree all the time. I always think that we need to, use an approach like a top-down, really protect and restore headwater streams as much as possible, because then, the downstream part of the ecosystem will, hopefully either recover by itself a little bit or improve, or at least you protect whatever measures have been implemented downstream. So I really encourage whoever is working in the Patuxent watershed to really take a close look at what can be done in the watershed and then at the headwater streams, and then go downstream from there.
So I'd say a couple things. One is, at least from Anne Arundel County, sort of south, certainly on the eastern shore of the river, but you think even on the western shore, the Patuxent, surprisingly, there are certainly pockets of intense development, but a lot of the Patuxent is actually relatively undeveloped still. But there are lots of problems on many of these agricultural properties. So I think trying to make inroads with agricultural property owners and looking at opportunities but both for better management of those properties, but also opportunities to correct some of the historical impacts on those properties that really don't have anything to do necessarily directly with the agricultural use. So making inroads there, and the other thing that really concerns me a lot, frankly, is in the more urbanized portions of the Patuxent, particularly for us around the Little Patuxent. Both in Howard County, Prince George's, Anne Arundel County, Laurel, there continue to be encroachments into the floodplain area of the Little Patuxent, and that's a big river system. That's a system where we should be creating a pretty, in my opinion, hard and fast no-go zone for new development activities and trying to pull development activities out of the floodplain of both the Little Patuxent and the Patuxent, because we're not only putting that development activity at risk, we're impacting the riparian wetlands and forest of those systems. And I just think we should know well enough now that we're not doing that anymore. And I still see it happen. That's I see it happening across jurisdictions. So those are things that I would see as priorities.
Yeah, especially with climate change and flooding and all that is going to be happening. So.
Well, I would like to say that on behalf of the PaxCon Planning Committee, that we are so thankful for everybody joining us today. It was very interesting and very informative, as the chat is responding to, and we welcome you to join us for our next webinar in the series, which is the last one on November 19th. Again, thank you all for joining us, and thank you very much to our speakers, Solange and Erik. We loved having you. Thank you so much.
Thank you.
Thanks. Appreciate the opportunity.